Welcome to my channel. In this video, I am going to discuss linear and nonlinear systems. Now consider one system and its input x of t and a corresponding output is y of t. So this input is also called the excitation and yt is called response. Now we need to understand whether the system is linear or nonlinear. A system is said to be linear if it follows following two principles. These are homogeneity and additivity. Now the homogeneity, it says that if we multiply some constant with the input signal, then it is fed to the system, then the corresponding output is also multiplied by same factor a from previous output. Means it should be a times y of t. Its meaning is that if input signal is amplified by certain factor, suppose it is amplified by 2, then output signal should be also amplified by the same factor 2. Okay, then only it is linear. When you see for nonlinear system, this is not true. Okay. Next one is additivity. And for this, if I consider two signals, one signal is x1t, that is one time it is applied to the system, and that time corresponding output is y1t, and again next time if we apply different signal x2t and corresponding output is y2t, right? So these two are known for certain system. Now if I take one linear combination, simple combination of these two, x1 plus x2, this one, if it is applied, the addition of these two additivity, so x1t and x2t, these two are added, then it is applied to the system, then the output is simply addition of previous outputs y1t and y2t. So y1t plus y2t means if input sides signals are additive, then corresponding outputs are also additive. Okay, so this is called additivity. Now for linear system, both the laws should be correct. So system should follow these two properties. If any of these two properties are violated, then system is said to be non-linear. So you can check any of these two. So if suppose homogeneity is violated, then directly you can say it is a non-linear system. Okay. Suppose if this is true, then you need to check the next one, additivity. So both should be true, then only it will be called linear system. Now combination of, we can combine these two laws, okay, and that is called as principle of superposition. Okay, so we can combine these two. Now we can consider one linear combination of input signals a times of x1t and b times of x2t, where a is one constant, b is another constant. So after taking these two constant, then if we combine these two signal and that is applied to the system, then system, if it is producing corresponding outputs like a y1t plus b y2t. You see, for x1t corresponding output is y1t. So as a is multiplied, here also a is multiplied, and x2t is different signal, its multiplication factor is v, and its corresponding so x2's corresponding output is y2t. So y22 is again multiplied by same factor v. Now they are combined. Okay, so this is very similar. So a x1t plus b x2t, it's if its output is a y1t plus b y2t, then it is said it's a linear system. So this is called superposition principle. And you have seen that in circuit theory, this RLC, this resistive, inductor, and capacitor network, it is always a linear system. And in that linear system, superposition principle is applied. So in the circuit, if you have more than one signal, so you can consider one signal at a time, okay? Then you can find the corresponding output. And next time, you'll consider another signal, keeping other signals 0. Then again, you will get the result, the output signal. Then at the end, when both the signals are present, then the output will be the addition of those two previous outputs. So that kind of superposition principle will use in linear systems. Okay, now here we'll discuss a few examples of these linear and nonlinear systems. Okay, now first example is y of t equals to x squared t. So we need to check whether it is a linear or nonlinear system. So first we will check the law of homogeneity. So x of t is applied to the system and we'll get y of t, which is x squared t. This is given by the system natures. Okay. Now, if I consider one signal x1t, which is a times of xt, so we have multiplied a with this signal xt, we have got a into xt, that is a new signal. If it is applied to system, then what is the corresponding output? And that output we need to check whether it is again a times of yt or not. Okay, if it is again a time of yt, then it is called homogeneous system. Okay, so we'll consider so corresponding output y1t. So by this definition, y1t should be the square of the signals. So now signal is x1, so the square of the signal is x1, so x1 squared. Okay, now we can replace x1 t by a into xt. That's square. Now this we can simplify as a squared times x squared t, right? Now we can replace x squared t by yt. So it is giving a squared times yt, y of t. So this is not same as a times yt. Rather it is a squared times y of t. So as it is not same as a time of y of t, not same factors, it is square of that factor, it is amplified. Okay, so in this device, if input signal is amplified by 2, then output is getting amplified by 4, 2 square. If input signal is amplified by 3, then output signal is amplified by 3 square, 9. So it's not in semi proportionate. Thus, it is not a linear system. So this is non-linear system. Next, consider this one. Y of t, any signal x to the power p of t. So if p is not equal to 1, other than 1, okay, then every time you will get the factor a to the power p. And a to the power p is not same as a, because if p is not equal to 1. Then obviously the system is going to be non-linear. Okay, so any system of this kind, x to the power p of t, when p is not equal to 1, like x to the power qt, x to the power half t, x to the power 5t, anything, all systems are non-linear systems. Okay, this is very easy. Okay, so if the power is 1, then only it could be linear, right? Now we'll consider this thing. So its power I have considered 1, so x of t. Now just I have added one constant k. Okay, so x of t plus k is one constant independent of time. Okay, this is one system. You see, this kind of equation y equal to x plus c, it's a linear equation, but we need to study whether this kind of system is linear or not. Okay, this is interesting. Now we'll consider superposition principle. Now consider that x1t is applied to a system, so corresponding output is y1t. So that one I can write x1t plus k, right? Similarly, if we apply x2t, the corresponding output would be y2t equals to x2t plus k. Now, if I consider linear combination of these two, ax1t plus bx2t, that is a composite signal. Suppose it is x of t, okay, that is applied to system, then the corresponding output yt is that x of t plus k, that I can write this x of t, x of t. So signal plus one constant k, that is the nature of the system. Okay, so that thing again I have considered. Now we need to understand this y of t is again linear combination of these two or not with same factors a y1t plus b y2t. If it is same, then only it is linear, otherwise it is non-linear. Okay, now we need to replace this x of t. So I replace this one a x1t plus b x2t plus k. So this is actual output of the system. Okay, now we need to understand that this linear combination a into y1t plus b into y1t, this its value, whether it is same as this thing or not. Okay, so I'll consider this thing a y1t plus b y2t. So we'll find this its value. So we replace a y1t and y2t from here. So a into this one is replaced x1t plus k, b into x2t plus k. Now we can rearrange. We can consider a x1t and this one is b x2t first, and this a k plus b k. So k I can take common. This a plus b k. So you see, this is your exact output a x1t plus b x2t plus k. Here this value is a x2t x1t plus b x2t plus a plus b times k. So here it is only k, it is a plus b times k. So these two are not same for all values of a and b. Okay, not the same factors. Okay, so actually this is because this signal is giving this constant value k. This signal is again giving one constant value k. So when a is multiplied, then it will produce ak, and when b is multiplied with this one, it will produce bk. So total will be ak plus bk. Okay, so thus as these two are not same, so I can say this is not equal to exactly y of t. So superposition principle is not true. So this is non-linear system. So be careful here. So students are making mistake here maximum times. So when this is added, this is not linear system. So its power is 1, though its power is 1, but because of this DC added, so this is called offset of the system. So when signal is absent, is 0, x is 0, then also we'll get certain output k. Okay, so this is constant output. Fine. So this is called non-linear system. So what are the linear system? Is it a linear system? Y of t equals to phi of xt. Yes, its power is 1. It is 5 times. So you can see if we multiply 2 times here, so again output is also multiplied by 2 times. Right? So it will follow both homogeneity and additivity. So this system is linear system. What are the other systems? So I can consider one derivative. So yt equals to 4 times ddt of x of t, a differentiator. It's a linear system because if xt is multiplied by factor a here, that a we can take outside. Okay, so you see that a is multiplied with previous one, so homogeneity is applied. Again, if I have two signal x1t plus x2t, so derivative operator is distributive, so I can take ddt of x1t plus ddt of x2t. So means we'll get the output which is nothing but combination of previous outputs y1t plus y2t. So additivity is also true. So homogeneity and additivity both are true for this differentiator. So system is going to be linear system. Important thing. Okay. Similarly, integrator. Again, it is a linear system. Okay. Basically, this derivative and integrator integration, these two are linear operators. So if any linear operator is used on x of t, only x of t, then if we get the output y of t, then the system is linear system. Okay, that is useful. So if we use one linear operator on x of t and that is your output, then obviously the system is going to be linear. But if the operator is non-linear, then system is going to be non-linear system. Now consider this thing, y of t equals to absolute value of x of t. So this absolute operator, it's a non-linear operator that you can check. Okay, and this is a non-linear system. Similarly, sine of x of t, the sine function, it's also a non-linear operator. So this is non-linear system. Similarly, y of t equals to log of xt, exponential of x of t, or sine of x of t, all are non-linear systems because the operators are non-linears. Okay. Now consider y of t equals to x of t minus 2. So what is this? This system is basically a delay system. So you have applied x of t and you obtained one y of t which is x of t minus 2. So output is delayed by 2 seconds. So you are getting the same signal, only the delay. So system is linear again because you are getting the same natures, just only delay. So because if you apply a of xt, then again you will get same amplified version of signal, but again by 2-second delay. Okay. Similarly, if you have two inputs x1t and x2t, and the combination if you apply, then again the output you will get the delayed version of x1, again delayed version of x2, and their combination. That means corresponding output is delayed version of previous outputs. Okay, so thus additivity and homogeneity both are true. That I am not showing. I think you can prove it. So this is going to be linear system. Okay, so if there is a shift here, t is t minus 2 or t minus 3, whatever it is a linear system. Similarly, if there is a scaling factors 3, 4, 5 or half, whatever it is, time scaling factors, then also system to be linear system. Okay, you can prove it. And not only this, if we have y of t equals to 5 minus t by 2, both time shift as well as time scaling, both are there, then also it is linear system. So in general, y of t equals to x of any function g of t, if it is here within this one, x of, okay, so x of something function g of t, and g of t could be anything like x of sine of t, x of t square, x of log of t, does not matter. It is only x of, okay? Then the signal, this systems are all are linear systems, right? Not only this, again, if g of t is multiplied with x of t, so it is only x of t. With x of t, some function, time function, is multiplied. Then also, like this one, y of t equals to t times x of t, y of t equals to t to the power 4 times x of t, or y of t equals to sine of 2t into x of t, e to the power minus 3t into x of t. These are all linear systems. Okay, so any function, time function g of t is multiplied with x of t, it's also linear systems. Now, linear combination of linear systems. So if we consider some parallel combinations of linear systems, then we are going to add it at the end. Then total system is again going to be linear. Okay, so linear combination of linear systems is also linear. That is important. But in the combination, if you have one nonlinear system, so one linear, one nonlinear, that combination, so total system will become nonlinear. Okay. So you see, we'll consider these 4 cases. So first one, second and third, fourth. Now you see, first two are linear system. Why? Because this one 4 times x of t square. So here is a function. It is x only. It is fine. It is a linear system that I have said. Again, some function is multiplied here. Time function is multiplied here, tq, and x of some function of time. It's also fine. So this system is linear. This is linear. This is linear. So their combination is also linear. Second one, it is x of t minus 4, one delay system. This is another delay system, delay and time scaling system. So this is linear. This is also linear. So their combination is also linear. Now, if we consider next two, and I'm saying that these two are non-linear system. Why? Now here is sine operator on x of t. The sine operator is a non-linear operator. This is non-linear system. But okay, this is linear system because x of cos of t, whereas this part is non-linear. So non-linear plus linear is become linear. Sorry, non-linear. Okay. Similarly, x of e to the power minus t, this is linear system, but e to the power minus x of t, e to the power, the exponential power is a non-linear operator, thus it is a non-linear system. So total system is non-linear. Now, if we consider differential equations, so generally we will get this kind of differential equation in our systems like RC system, RLC systems equations. Everywhere you will see that differential equations will obtain. Okay, the relation between input and output is given by differential equation. And already I said that RLC circuit is a linear systems. Okay, so just looking at the differential equation, we can identify whether system is linear or non-linear. So what you will do, you will consider the power of these each elements. Okay, dy dt, yt, xt, and there shouldn't be any constant. Okay, so each power is only one. We can have higher order derivatives like d to the power 3y dtq, d square y dt square, dy dt yt, here dx dt xt. It's fine. So, but everyone is having only power 1, and this constants, this could be constant or function of time. Doesn't matter, right? Then system is linear. Be careful what I'm saying. I'm saying that power of each elements should be always 1. Okay, and the constant, this factors, this is multiplied, that could be function of time or constant, then it is linear. So thus these two, obviously they are linear systems. Now if I consider this one, you see t square is multiplied with dy dt. Here minus 4t is multiplied dyt. A sine of t is multiplied with xt. So you see all power dy dt power is 1, yt power is 1, and x of t power is 1. Just only some function of time is multiplied in the factors. So it is again linear system. Okay. Next, this one, if I consider 4 dy dt minus y squared t equals to 5 times x of t. And this is non-linear. Why? Because it is y squared. This term is power, the power of yt is 2 other than 1. Because of this, the system is non-linear system. Okay, I think just looking at the differential equation, you can identify whether the system is linear or non-linear. You can prove that one, okay, any one. So you will use superposition principle. You will consider first x1t and corresponding output y1t, okay, then again x2t and corresponding output y2t. Then consider one composite signal taking linear combination of these two, a x1t plus b x2t, and you will see that as the derivative operator is a linear operator, then always you can distribute everything, okay, and you will see that you can easily show the superposition principle is valid for this kind of differential equations. Okay, fine. Now I'll give you 5 small homework problems. Now you check whether your idea is clear or not. Okay, try to solve these 5 problems. These are interesting problems. If you can solve these 5 problems by yourself, I hope you will be able to solve any such problems. Okay, you can easily identify the system whether it is linear or non-linear. So here concern is whether the system is linear or non-linear, that you need to identify. Okay, these 5 systems are given. So you solve these 5 problems, you discuss this one, okay, and you understand whether it is a linear or non-linear, and whatever result you get, please try to mention in the comment section. Try to show that you are able to solve these things. Okay, if you can solve this one, then your knowledge is perfect. Okay, you will be able to solve anything. Okay, so please communicate your answers in the comment sections. I'll surely reply, right? And if you enjoy this video, then you may press like button. So and you can also share this video to your friends if you think it is suitable. And if you have not subscribed this channel, you may subscribe it if you want to get similar videos in futures. So thanks for watching. We'll discuss new topic in the next video.